what we're looking at here is problem 2 in your application sheet. And this one looks pretty intimidating, but it's not. Let me show you a couple things about it. So first off, all we're looking at are 5 separate studies, A, B, C, D, and E. So 5 different studies. And in each study, we had a population information. That is, what are we comparing it to? So I don't know what we're comparing. We don't have any words linked to this, but we know that whatever it is in study A has a mean of 60 and a standard deviation at 5. And in fact, as I look down my list, in every single study, we're comparing to that same population. But what differs in these are the sample scores, and our sample relates to population 1, the individuals that we think are different in some way. And you can see all of their scores are different. Then we come to this yellow region that's talking about what the researcher stipulates. So they stipulate alpha, and alpha is just the significance level. What odds do they want of possibly making a mistake? Or what are the odds of drawing a person with any of these scores at random? And so this first researcher said, well, I'll take 5% chance. The second one said, I'm only taking a 1% chance. And then we go on to the tails. You know about these, and those are going to differ. And all you have to figure out is the cutoff point, the sample z-score, and the decision, which is just reject HO or not, reject the null hypothesis or not. And over to the side, we have some little distributions that we can use to draw on. I know that you probably can't draw on the screen. Well, you should be able to now because hopefully you can. You can do it on paper and paste it in, but you should do it at this juncture because it'll help you. And then if you scroll down a bit, you'll come to a glossary. So if you've forgotten what any of these mean, you can just look down here and you'll see every single thing linked here. So let's go ahead and figure out the first problem. So we are given the mu of 60, standard deviation of 5, and our individual, or one person, got a score of 69. The researcher wants an alpha of 0.05 and a one-tailed high test, so we can go ahead and look up the cutoff point or the critical value. Let's type in the alpha of 0.05 and hit calculate. And we discover, scrolling down, we don't want a 0.06 there. Let's get the 0.05. We discover that we have a 1.65 cutoff point. So let's go ahead and write our Z alpha, our Z score linked to alpha equals 1.65. Now we need our sample Z score. I'll calculate by hand, and then I'll do a second example showing how easy it is to calculate in Excel. So we know that Z equals X minus M, but in this case, it's the sigma. It is mu because we're using Greek symbols because we know on a large population. And here is the Greek symbol sigma referring to standard deviation. So let's figure this out. We have in our first study A, we have 69 minus the mu of 60. And we divide by the standard deviation. And that brings us to 9 divided by 5, which equals, if you work that on your calculator, 1.8. So let's go ahead and solve the problem. Let's enter the alpha of, let me write the sample z-score in here. Z equals 1.8. Now, let's go on and make our decision by drawing on the chart. So here's the cutoff point, 1.65. Z alpha is 1.65. That means that everything in the extreme of this line that we've just drawn is going to be in the reject region, and I'm going to shade this reject region yellow. And now I'm going to use a different colored pen to mark our sample z-score, which is 1.8. So that would be about here. It's going to be between the 1.65 and the 2. So Z equals 1.8. We know that the fail region is everything that's not in the shaded region. So if the sample score had fallen anywhere in this right region, we would fail to reject HO. But because it falls into the shaded region, the researcher, here we go, let's get our red here. The researcher is happy. We've rejected the null hypothesis. And you can write out null hypothesis or just reject HO. Either way is fine, whatever you're comfortable with. All right, in our next test, we have similar information because our sample still has a mean of 60 and a standard deviation of 5, but our individual score is 50. So let's go ahead and substitute in. Let's see if we can just erase this 69. There we go. And let's just erase that 9. And let's erase the 1.8 because everything else here is the same. And that one doesn't want to erase, but we'll cross it off. So all we have to change here is the 50. So the z-score in this case is 50 minus 60 divided by 5. 50 minus 60 is negative 10 divided by 5. And here I'm going to cross that off because my eraser isn't working, which equals, cross that off too, negative 2. So let's go ahead and type in our information. First, I'll write in the z-score since I've already calculated it. Z equals negative 2. Now let's go ahead and look up Z alpha. We have an alpha of 0.01 in a one-tailed low test. So let's grab our calculator, our online calculator tool for the Z cutoff point. And here we go. And let's change that to 0.01. This researcher only wants a 1% chance of making a mistake. And we can see that with an alpha of 0.01, the right-tailed cutoff is 2.33, but we know it'll be the same for a one-tailed low test. We just add a negative sign. So let's go ahead and type in Z alpha. ZA equals negative 2.33. Let's go ahead and draw this on our chart so we can make a decision. So when we draw it, let's mark the negative 2.33, and here's the little tiny 2 way over here. So this is going to be like way out here. Z alpha equals negative 2.33. Now, in this case, since it's a negative test, everything to the extreme down here is in the reject region, and everything else, the vast majority of points, are in the fail region. So let's find our sample score. Z equals negative 2. I'll use red to mark it right here. Z equals negative 2. And we can see that our sample score is in the fail region. So our researcher is sad. This is not a significant result. A researcher might be sad depending on why he's testing. So we have to write that word fail to reject. I'm just going to write HO this time. Now, because it takes sort of a long time to work these out by pencil and paper, you're welcome to do it, but it is faster if you do it in Excel, so just take a look here. So first off, we can easily look up all of these cutoff points in advance. So let's go ahead and look up the cutoff points for these next 3 tests so that we can write them down. So in the first case, we have alpha 0.01 in a 2-tailed test. Well, that's what's still here. So we can see the critical value is plus or minus 2.58. So let's write that. ZA equals plus or minus 2.58. Next, we have 0.05 in a 2-tailed test. So let's see what that cutoff point is. Let's enter the 0.05. Calculate, and we can see the cutoff is plus or minus for the 2-tailed 1.96. And you know critical value means the same as cutoff point. So let's write that. Oh, I see a typo here. That should have been a minus, plus or minus 2.58. ZA for a two-tailed test with a 0.05 cutoff is plus or minus 1.96. And let's look up the last Z alpha too, just so we have this part of our job done. It's a one-tailed low using cutoff of 0.05. I see the 0.05 here. I'll hit calculate just in case. And we can see that the critical value is 1.65, but we have to add the negative sign. So let's write Z alpha is negative 1.65. ZA equals negative 1.65. Next, we can calculate our z-scores, but instead of working this all out by hand, let's work it out in Excel. Let's start with the equal sign. And let's go ahead and put that parenthesis and get the X for study C minus mu for study C. And now we can just divide by standard deviation. And here we have 1.4, that's our sample z-score. Now, to make life even easier, we could Control C to copy that, and we could just paste it. I'll use Control V, but you could right-click and paste however you want to. Let's double check and make sure this works. So here I'm going to click in this last one and see if it worked, and then I'm going to move my cursor up here into the formula bar, and you'll see these colors appear. And so I can see now that it took X, that's what I wanted. It subtracted. In red, I can see the M, and it divided by the standard deviation. I can see in the purple up here and the purple here. My parentheses are in place. So Excel did a nice referential formula and figured out all these z-scores using copy and paste. Now we can go ahead and draw these on our distribution. And for the sake of just making it a little bit easier in this demonstration, I'm going to take all of this out, solve a couple of these problems. And so let's go ahead and do some drawing. I'm going to start with C right here. We have Z alpha of plus or minus 2.58. So let's write those in way the heck out here. Z alpha equals negative 2.58. And way out here somewhere, we have Z alpha equals 2.58. We can shade the tails of the distribution, tiny, tiny little amount of space, and we can indicate that the fail region is anything else that falls in the white there. Our sample z-score is 1.4. So, oh my goodness, let's mark it in red. Nowhere, anywhere near those tails, z equals 1.4. And so it falls within the fail region, so we fail to reject HO. In our next example, I'm going to just erase this because we have another two-tailed test. But let's see now what our cutoff, now the fail region is still going to be in the center, but our cutoff point in this test is plus or minus 1.96. So let's go ahead and mark these cutoff points, which are going to be here, minus 1.96. I know that because here's the -1, you can't see it well. Here's the -2, and this minus 1.96 is going to be pretty close down here. Here's another negative 1.96. Here's Z alpha. Here's another Z alpha equals 1.96. We know our shaded region now is going to be all of this space. We've taken that 5% and we've divided it between the two tails, and our sample score is minus 2.4. So our sample score is way here. Let me get my red here. This is our Z score equals minus 2.4. And that clearly falls in the reject region, in the shaded region. So the researcher is happy. This is a significant result. We can reject that null hypothesis. I'm just going to write H with that little O this time. And finally, we have the last test. It's a one-tailed low. So I'll leave some of that shading in here, but I don't know where the cutoff point is, so I'll move that. And I'll get all of this out of here because nothing in that, whoops, I don't want that. There we go. Now you can't, maybe you can draw on this. You should be able to. They arranged that for each of you, but if you can't, you can do it on paper, but you should definitely do this at this stage. So let's go ahead and fill this one in for this last one. Z alpha is minus 1.65. It's falling right about here. Let's shade in the tail of the distribution. Since it's one-tailed low, we need a score. We have a lot of room there, don't we? And we have a z-score of 2. So let's put that in here. And we can see that our sample score falls within that shaded region. And whenever it falls there, we reject HO, and that's a significant result. So I hope you benefited from this demonstration of how to solve these, make these decisions using both calculating by hand and using Excel.